So now today we're going to look at some rational functions. And rational functions are just the ratio of polynomial functions. So I always think rational, ratio, that's kind of the word of rational. And as we're doing this, we're going to take a look at just some x-intercepts, y-intercepts, what happens, can we tell what's going on algebraically, and take a look at the domain. Okay, so algebraically we are going to determine the y-intercept for this function. So anytime you're finding a y-intercept, we're going to think make x equal to 0. Okay, so f of 0, anywhere I see an x, I make it a 0, and we simplify. So I'm going to have 6 over negative 3, so that tells me my y-intercept is going to be negative 2. So my y-intercept is located at 0, negative 2. Okay. To determine the x-intercept of the function, it says think fraction can only equal 0 if its numerator is a 0. So an x-intercept, we would always say make y 0. Well, in this case, y being your fraction, in order to make a fraction 0, I need to make my numerator 0. So I'm only really worried about my numerator. So even though it really is looking maybe like this, in order to solve to make that 0, I only have to focus really on the top. So when we're solving this, I'm going to subtract over the 6. So now I'm going to see 6 is equal to x. And so I can tell you here, your x-intercept is going to be at negative 6, 0. Okay. For what value of x is it undefined? Okay, well, a fraction is undefined when its denominator is 0. You can't divide by 0. So if I want to know when is my denominator 0, I'm going to set that equal to 0 and solve. Okay, so why is it undefined? You just can't have a denominator with 0. I can't divide by 0. Okay, so based on C, it says we're going to state the domain of this function in set builder notation. So set builder, we get our fancy brackets. We can say x such that x does not equal 3. So I want all real numbers except for x cannot equal 3. Okay, number 2, we're going to kind of take a look at the same thing. Find all values of x for which the function is undefined. And we're going to verify by using our calculator to evaluate for these values. Okay, so we are going to say same thing. If it's undefined, my denominator would be 0. Okay, and I don't really want it to be 0, so we're going to solve and find all the places that would make this 0. So we have to do some harder trinomial factoring here. I have to find something that's going to multiply to be negative 12 and add to be 11. And the factors that are going to work here are 1 and 12. Remember, sign of the middle term is positive, so that means my larger number is positive. My smaller number then has to be negative. Okay, so we copy the first term. We're going to split that middle term up into the 2 factors that we just found. So we're going to find a negative x, and we're going to find a positive 12x. Copy your last term. And now we want to think factor by grouping. Oops, too far. Let's try that again. Factor by grouping. There we go. Okay, so out of that first term, I could pull out an x. Okay, and so what I'm left with here is 2x minus 1. Now, out of my next term, I could factor out a 6, a positive 6. And so now, again, what I'd be left with is 2x minus 1. Remember, you want that factor to be the same. It tells you that you factored correctly. So I have one factor from the stuff on the outside, and I have that repeated factor makes my other one. Okay, so if we set each of those factors equal to 0, we're going to find x is equal to negative 6. And we would find x is equal to 1/2. Each of these places, if x is negative 6 or x is 1/2, will make your function undefined. And if you wanted to check this on your calculator, you could plug that in and you could go to the table, and on your table you would see at negative 6 it says undefined. At 1/2 it says undefined. You could also plug that value in and let your calculator simplify it out for you, and it would still give you an error or an undefined. Similar idea, it's just asking what is the domain. Okay, so same thing, what's the domain? I'm going to have to solve, and I need to find where are my restrictions in the denominator. Okay, so we're going to have to factor this. So something that's going to multiply to be negative 16 and add to be negative 6, and we're looking here at how about negative 8 and positive 2. Okay, so setting these equal to 0, I can see x is equal to 8, and I can see x is equal to negative 2. So this is where it is 0 in my function, in the domain. So it can't equal negative 2, and it can't equal 8. Both of those places would make that statement undefined. Okay, so I would be looking for choice 3 here. If x is negative 2, I get a 0 in the denominator. I don't want that. If x is 8, again, I get a 0 in the denominator, and I don't want that. Compositions of functions. We haven't looked at this in a while. View for composition of functions, you're always working inside out. The only difference here is we're just working with a rational function for one of our functions. So very first thing we're going to do is find the g of negative 2. So I go into the g function, and anywhere I see an x, I make it a negative 2. So I have 3 times negative 2 minus 2. So that would get us 6. Negative 6 minus 2, and negative 6 minus 2 gets us a negative 8. So now I know the g of negative 2 is a negative 8. Okay, so this part here simplifies to a negative 8. Now I'm going to the f function. And in that f function, anywhere I see an x, I'm now making it a negative 8. You just have to remember we have a fraction that we're dealing with here. Okay, simplifying our numerator, 2 times negative 8, I get a negative 16, plus 1, I get a negative 15. Denominator is going to simplify down to how about a negative 3, and when we reduce this in total, negative 15 divided by negative 3, we get a positive 5. Okay, we'll try another one. We're going to try letter B. So letter B, same thing, I have g of positive 2. So again, we're going to start with the g function. So starting at g, I'm going to plug in a 2. So we have 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2, we're going to get 4. So the g of 2 is 4. So again, if I think about that, that means this section here is 4. So now I want to find the f of 4. Okay, so we have 2 times 4 plus 1. And now I have 4 plus 5. Okay, so our numerator, 2 times 4 is 8 plus 1, we get 9. On the bottom, we get 9. So that means this whole thing then is going to simplify down to 1. Okay, so what happens if it's an x? Well, same thing. We just do the same process. This is saying in the f function, anywhere I see an x, I'm going to make it g of x. So I go into the f function. Anywhere I see an x, I'm replacing in that f function. Oops. I'm going to replace my g of x function, which is 3x minus 2. Okay, so I go to the f function. I have a fraction. I see 2, and now I see an x. So I'm replacing that x with 3x minus 2. And I still have a 1 at the top. We go to the bottom, and on the bottom I have an x. So right away I'm doing 3x minus 2, and then I have a plus 5. So I can see in parentheses, that's the g function that I'm plugging in for the x. And now we need to simplify, so distribute the 2 on top. So we have 6x minus 4 plus 1. And on the bottom, parentheses aren't really going to do too much, so I could just combine like terms. I have 3x, a negative 2, and a positive 5 is going to give me a positive 3. Okay, so my numerator now, 6x minus 3. And so I can simplify this more because I can factor out on both of these a 3. So this will leave me with 2x minus 1. This will leave me with x plus 1. These 3's go away. And so your final answer for all of this is just going to be about 2x minus 1 over x plus 1. So that's a composition of functions with fractions, with rational expressions, and keeping an x. Probably your hardest composition you'll get. Okay. Now we're going to look at inverses with rational functions. So remember, the first step that we did for inverses was we switched the x and y and solved for y. So same thing we're going to do here. So switch the x and y. Now we're going to solve for y. So to solve, I'm going to have to think, multiply each side by y minus 2. Distribute that x through, so we have xy minus 2x. And I want to get y's together. Okay, so no matter what, I got to get y's by themselves. So what I'm going to do is I'm going to subtract over the y, but I'm going to add over the negative 2x. So we have xy minus y. Now adding over the 2x, now I can see my y's are all on one side of the fraction, or one side of the function, I should say. Okay. This allows me to factor out the y. Remember, we're trying to get y by itself. Okay, so now we factored out the y, and I have x minus 1. And I want to get y by itself, so I'm going to divide each side through by that x minus 1. So every time you're doing this, you want to tell yourself, I want to get y by itself. So we have 2x over x minus 1. Okay, remember this f of negative 1 notation? That's that y notation. Okay, we'll try letter B. Switch the x and y. We want to solve for y, get y by itself. That first step, we got to think cross multiply. So really, this is just the same thing as 2xy. And I want to get the y's all on one side. So that means this guy's got to come over here. Subtracting the y. And now remember, I want to get the y's by themselves. So I'm going to factor out that y. And now, keep wanting to get y by itself. I got to divide through by this factor. Okay, so we get something that looks like 3 over 2x minus 1. And again, remember that inverse notation is saying f to the negative 1 of x. For our last one, we're trying to decide if it's an even or an odd function. So let's just do a quick review here. If it's even, that means our original function is the same as when I put in a negative x. Maybe another way we could say it is opposite inputs gives same outputs. Okay. If we have an odd function, here's our notation for odd function. Verbally, what this is saying is our opposite inputs give opposite outputs. Okay, so we need to test. So what we need to see is what happens if I plugged in a positive 4 or a negative 4, or I could pick any number. I'm just picking 4. You could pick 2, you could pick 1, you could pick 3. I usually stay away from 1s and 2s and 0s because sometimes those produce some odd results. So maybe if we try 4, you could try 5, you could try whatever you want. What we're going to try here is what happens when I take this function. We'll try 4, see what happens. So I have 4 squared minus 8 over 4 times 4. So if we simplify this, this gets 16 minus 8 over 16. So 8 over 16, I get 1/2. Okay, so I can see here, I had an input of 4, I get an output of 1/2. Okay, so if I tried the opposite of that, what happens if I try the opposite? Okay, so now again, I have negative 4 squared minus 8 over 4 times negative 4. So negative 4 squared, I get 16 still, minus 8. But on the bottom, I get a negative 16. So I still have an 8 in my top and a negative 16. So now this time, I get a negative 1/2. Okay, so looking at this, I can see an opposite input gives an opposite output, which tells me my function has to be odd. And you could graph this out. You could use your calculator, and if it looks the same right side up and upside down, you can tell it's an odd function. It needs to be symmetric to the origin. Okay, I hope this helped. If you have questions, bring them into class, and we'll go through them. Hope you guys have a great day.